Good afternoon, everyone. Today's research title is a Geo-environmental and Economic Multi-Criteria Framework for Land Use Land Cover Driven Condominium Site Suitability in a Rapidly Urbanizing Sri Lankan Suburb. I am Udar Danushka, co-author of this research, currently working as a trainee scientist at National Building Research Institute, Sri Lanka. The author of this research is Dr. Thisara Sathsara, who is currently working as a senior lecturer at Department of Geography, University of Jayewardenepura. The other authors are Professor Reverend Pinnavala Sangasumana, Professor Sunethra Thennakoon, Mr. Sumajit Kumara, and Mr. Ranjana Geethalankara. Here the quick overview of today's presentation. Introduction. Urban land use change is a direct consequence of increasing population in urban areas. As urban population grows, cities face increasing pressure to provide adequate and affordable housing while minimizing unsustainable urban sprawl. In response to limited land availability, residential developers are increasingly shifting towards vertical development rather than horizontal expansion. In this context, condominium development has emerged as a key solution for densely populated urban areas and rapidly growing cities experiencing land scarcity. However, despite these trends, there remains a significant research gap in the systematic assessment of condominium suitability in rapidly urbanizing suburb context in Sri Lanka. In particular, limited studies have focused on identifying optimal location for condominium development in areas such as Kaduwela DSD using geospatial and multi-criteria decision-making approaches. Problem statement. Rapid urbanization in Kaduwela DSD has increased the demand for condominium development. However, despite the availability of numerous geo-environmental and economic factors influencing land suitability, limited research has been conducted to systematically identify the most suitable location for condominium development using geospatial techniques and multi-criteria analysis. To fulfill the research gap, this research was conducted. In this research, main three research questions were asked. The research questions are: what are the key factors influencing land suitability for condominium development? Which location are the most suitable for condominium development? How valid and feasible the proposed suitable sites for condominium development? Research objectives. The general objective is this research to develop a geo-environmental and economic multi-criteria suitability framework for identifying optimal condominium development location in Kaduwela DSD using geospatial tools and techniques. Specific objectives are set to fulfill the general objective and also to address the research questions. The specific objectives are to identify geo-environmental and economic factors that influence in land suitability, to identify the most suitable location for condominium development, to assess the validity and feasibility of proposed site for condominium development. In this research, two hypotheses were tested. The null hypothesis is there is no significant relationship between geo-environmental and economic factors and land suitability for condominium development in Kaduwela DSD. The alternative hypothesis is there is significant relationship between geo-environmental and economic factors and land suitability for condominium development in Kaduwela DSD. Let me introduce our study area. Kaduwela DSD is our study area for this research. It is situated within Colombo District, Western Province in Sri Lanka, and it is the third highest populated DSD in Colombo District, and its population is steadily growing and housing demand is also increased with it. And condominium development proposals are already come into this area. So it is important to know which locations are more suitable for condominium development or not. Research methodology. Our research mainly follows 5 steps: data collection, factor analysis, AHP weighting, weighted overlay analysis, and result validation. The first step is data collection. We gathered both primary and secondary data. The secondary data, most of the secondary data gathered from government institution. The second step is factor analysis. We identify 7 key factors that influence land suitability for condominium development. The third step is AHP weighting. This standard systematic approaches for compare the factors, and according to the AHP method, weighted values were given. The fourth step is weighted overlay analysis. And the final and fifth step is result validation. This table shows the factors, data sources, and which analysis method we used. Here's the methodological flowchart of our research. The first we produce proximity to services map based on the distance to services, then produced integrated land value map, then assign weighted value for each criteria according to the AHP method, and finally we produce land suitability map for condominium development. Data analysis. First, we produced proximity to services map. 6 essential services are being taken into consideration, such as public transport hub, hospital, supermarkets, schools, town centers, and banks. To produce the proximity to services map, weighted overlay analysis was conducted and weighted value was given according to the AHP method. Land value. Land value is one of the key factors that should be taken into consideration when selecting a land for condominium development. And here, integrated land value map was produced by combining real land value from the government valuation department and the proximity to services map, as land value always vary on service accessibility. This slide shows the other reclassified 5 variables, such as land use and land cover, water bodies, slopes, road network, and population density. 13 categories of land value can be identified within this area according to the survey department data. When considered about the water bodies, Kalani River can be identified as the major water source in this area. Moderate slope area are more suitable for condominium development to avoid the effect of landslide. Proximity to roads allows easy access to services and helps fulfill daily needs. When considered about the population density, condominium development is highly suitable for densely populated areas. This slide shows the 7 factors that we used and AHP value each one was given. The most important factors is land use and land cover. It covers 13 categories of land use and land cover, which received 21%. Then the second factor is land value. It received 18%. And third factor is proximity to services. It received 16%, and it covers 6 essential services people want to live close to. Water bodies received 15%. Slope received 14%, and road network received 10%, while 6% was given for population density. This slide shows the final land suitability map for condominium development, and the study area were classified into 5 classes based on suitability. Highly suitable area covers 19.25 square kilometers with excellent access to services and good road connectivity with the low environmental risk. Suitable area can be identified as the large portion of this area. It covers 24.63 square kilometers. Moderately suitable area covers 20.53 square kilometers and 15.69 square kilometers for less suitable areas and just 4.83 square kilometers for least suitable areas. To ensure our suitability map is accurate, we conduct an accuracy assessment, and based on 100 random sample points, and overall accuracy was reported as 95%, meaning 95 point out of 100 were classified correctly, and kappa coefficient value reported as 0.9067, confirming that our suitability map is reliable and trustworthy for construction purposes. Our conclusion and recommendation, our research is set out to test two hypotheses and null hypothesis was rejected. Based on our analysis, we make 6 key recommendations. Prioritize zones within 500 to 1 kilometer of school, hospital, and town centers for high quality of life. Preserve green spaces and maintain safe distances from the water bodies to mitigate environmental risk. Focus development on moderate slopes to balance construction feasibility and stability. Improve services in moderately suitable areas to unlock long-term development potential. Avoid flood-prone zones and steep slopes. Apply mitigation measures where unavoidable. Adopt and regularly update the GIS-based suitability framework for data-driven urban planning. Here's the references. And that's all. Thank you.